Hello students, today we are going to verify the Euler's formula. Let us introduce what are dimensions. What is this? A point or a dot. It is assumed that a dot is of no dimension. Let us take 2 points. We know that a line can be drawn passing through these 2 points and which is of 1 dimension. Let us take 3 non-collinear points and a 2-dimensional figure can be drawn which is a triangle. So, joining the second and the third. So, this is nothing but a triangle. Let us take 4 points. Is it possible to make an object? Yes, and an object is tetrahedron, which is of 3 dimension. Now, let us take some concrete objects. What is this? A cube. When we cut this cube, say suppose from this first side, what we get? Let us cut with the help of this cutter. If we cut this first side, we get this one leaf. Then from the second side, this second portion, and when the third side, as you can see, what is formed? A net. So, as you can see, this is nothing but a net of a cube. Can you count the number of faces, edges and vertices? Question arises, what are faces? As you can see, these are polygonal faces, or we can say the polygonal regions are nothing but faces. And in this one of the polygonal face, how many corners are there? 1, 2, 3 and 4. So, in this polygonal face, how many vertices are there? 1, 2, 3 and 4. And when we meet these 2 polygonal faces, a line segment which is 1, 2 is formed. And this line segment is nothing but an edge. So, can you count now how many faces, edges and vertices are there in a cube? So, how many faces are there? 1, 2, 3, 4, 5 and 6. This 5 and 6 is nothing but the bottom and the topmost face. Now, so what we get is faces, where f is denoting the number of faces, which is equal to how many? Let us again count it. 1, 2, 3, 4, 5 and 6. 6. Now, let us count edges. Let us denote it with E. Now, as we can see, this vertex, the polygonal vertices 1, 2, 3, 4 and this vertex 1 and 2 is forming a line segment. In this 5th polygonal face again, 1 and 2 is forming a line segment. And when we intersect, or we can say meet, a line segment which is an edge of a cube is formed. So, first edge is 1, 2. Similarly, when we meet second and 5th face, second edge, 4th and 3rd face, 3rd edge, 5th and 4th face, this is 4th edge, 4th and 6th face, 5th edge. Now, as you can see, we have already counted how many edges? 5 edges. 1, 2, 3, 4 and 5. Now, this polygonal face, which is the first face and the fourth face, intersect. As you can see, is again second and third. This edge. So, which number is this edge? As you can say, this is sixth one. Now, the first and second, seventh, 5 and 8, eighth, and also we can see 6th and 7th is the 9th one. 9. Now we can see these are 9 edges of form, and when we cover this topmost face, how many edges we are getting? 9. We were getting 9 before, now 10, 11 and 12. So, how many total number of edges are there in a cube? Let us count once again. As you can see, this is forming a cube. 1, 2, 3 and 4, 5, 6, 7, 8, 9, 10, 11 and 12. So, how many edges are there in a cube? 12 edges. And we know that when these edges intersect at a common point, a vertex is formed. So, what is the vertex of a cube? As you can see, 1, 2 and 3. These 3 edges are intersecting at a common point, which is known as vertex and which is named as 5. So, this 5th point is known as a vertex. So, similarly, how many vertices are there in a cube? Count them. 1, 2, 3. These 3 edges are meeting at this common point. So, 1, 2, 3, 4, 5, 6. As you can see, this leaf, again 3 edges are intersecting at this common point. What was the counting? 4 were the bottom, then gives out you 5, 6, 7 and 8. So, how many vertices are there in a cube? Let us denote it with V. It is 8. Let us take another example. What is this? As we have already discussed, this is nothing but a tetrahedron. And again, if we cut this, a net is formed of this shape. Now, with the help of this net, now can you count the number of faces, edges and vertices? Let us count it. 1, 2, 3 and 4. These are the number of faces. So, let us denote it with F1. So, how many number of faces? 4. Now, edges, let us denote it with E1. How many number of edges? Again, you can see that this polygonal face, or let us see in this only. 1 and 4 intersecting the polygonal region, this and these 4 polygonal regions, and when we intersect this polygonal region, this line segment where the polygonal regions has 3 corners, 1, 4 and 2. So, 1, 2, 3. Again, as you can see, 1, 2, 3, 4, 5 and 6. So, what are these? 6 are the number of edges, or we can say total number of edges in a tetrahedron are 6. Now, vertices. Let us denote it with V1. This was a tetrahedron. This edges are meeting at again a common point. So, how many vertices are there? 1, 2, 3 and 4. So, vertices are 4. Can you observe any relation from these 2 examples? See this. In first example, if we add vertices in faces and subtract edges in it, we get 6 plus 8 minus 12. As we know, 6 plus 8 is 14 minus 12, which is equal to 2. Again, see in the example 2, faces, edges and vertices. Again, what we have to do is, in faces, we have to add the number of vertices, and then from the sum, we have to subtract the edges. What we get is 4 plus 4 minus 6, which is 8 minus 6 again comes out to be 2. You can see that this is nothing but the Euler's formula. This was introduced by Euler. Thus, what we can say that the Euler's formula is F plus V minus E is equal to 2, where F is the number of faces, V is number of vertices and E is number of edges. Now, you can yourself explore some of the examples with the help of an activity, for example, hexagon, cuboid, sphere and cylinder, and verify whether Euler's formula is satisfied or not. Thank you.